Hello, my name is Zachary Marfori and my partner on this project is Ulises Cruz. Today I'm going to model how you can write algebraic equations for the purpose of solving real-life problems. This covers Common Core Math Standards 7.EE.4 and 8.EE.7. They give us the problem. Greg buys 5 bottles of water. He has coupons for 65 cents off the regular price of each bottle. After using the coupons, the total cost of the waters are $6.20. What is the regular price of a bottle of water? Okay, so we know that there are 5 bottles of water that each have an unknown price. We also know that there are 5 coupons because in the problem it states that Greg has a coupon for each of the 5 bottles of water. And since there are 5 bottles of water, there are 5 coupons. The problem also states that the cost after the coupons were added is $6.20. Since we know the total cost of the 5 bottles of water after the coupons were added, we can start to build our equation to solve the problem. We can put $6.20 as our total for our equation. So, because we don't know the price for each bottle of water, we can set a variable to represent the cost of a bottle of water. So, let x equal the cost of one regular bottle of water. Okay, so to find the total cost of 5 bottles of water, you must multiply the cost of one water by 5 to find the cost for 5 bottles of water. We can also do the same thing with the coupons. We multiply the value of one coupon by 5 to find the amount of money they can take from the 5 bottles of water. The cost of 5 bottles of water can be represented by 5x because x stands for the cost of one bottle of water. The cost of 5 bottles of water can be represented by 5x because x stands for the cost of one bottle of water. And the amount of money the 5 coupons can take from the price can be represented by 5 times 0.65 because the value of one coupon is 65 cents. So, because the coupons deduct from the total cost, they can be shown as subtraction from the total cost of the 5 bottles of water. Now, because we know that the cost of 5 bottles of water can be represented by 5x and the coupons can be represented by 5 times 0.65, we can show the coupons deduction from the bottles of water as 5x minus 5 times 0.65. Although this expression can be used, there is a better way to solve this. So, because to show a coupon deducting from one bottle of water is x minus 0.65, it can be multiplied by 5 because there is 5 of each, thus giving us 5 times in parentheses x minus 0.65. Okay, so now we can finish our equation. The finished equation is now 5 times in parentheses x minus 0.65 equals $6.20. Now, the first step of solving the equation is to distribute the 5 because this is in distributive form. 5 times 5x is 5x and 5 times 0.65 is 3.25. Once done distributing, the equation now becomes 5x 5x minus 3.25 equals 6.20. Okay, never mind. Now, in order to solve this equation, we must isolate the variable. And what I mean by isolating the variable is getting the variable by itself on its side of the equation. In order to do this, though, we must use two properties. These properties are the addition property of equality and the division property of equality. The addition property of equality says that if you add something on one side of the equation, you have to add the same thing to the other side to keep the equation equal. This is the same for the division property of a 3.25. We will add the 3.25 to that side and to the other. So now you're left with the equation 5x equals 9.45. This is where you use the division property of equality to finish. Because the opposite of multiplying is dividing, we will divide 5 on both sides of the equation. The 5's cancel out and 9.45 divided by 5 leave you with x equals $1.89. Since we have isolated the variable completely, we know that x equals 1.89. Now, if you want to check this, you would replace the x in the original equation with 1.89 to check for equality. This would look like 5 times, in parentheses, 1.89 minus 0.65 equals 6.20. To check the problem, just solve the equation. So you would first distribute the 5 to 1.89 and 0.65, 5 and 0.65. So you would first distribute the 5 to 1.89 and 0.65. Okay. After that, you do 5 times 1.89 is 9.45 and 5 times 0.65 is 3.25. Now the equation becomes 9.45 minus 3.25 equals 6.20. Now, you get 6.20 equals 6.20. Since 6.20 is equal to 1.89, so wait. Since 6.20 is equal to 6.20, I meant $1.89 is the price for one bottle of water.